What if the space-filling ether exists? How would it impact the theories of relativity? The concept of ether, or ether, is a historically significant idea that dates back to the ancient Greeks. It was believed to be a medium that permeated all of space, and through which light and other electromagnetic waves propagated. However, the concept of ether became scientifically untenable with the advent of Einstein's special theory of relativity in 1905. The Michelson-Morley experiment in 1887 had already produced results that contradicted the ether theory. The experiment attempted to detect the relative motion of matter through the stationary luminiferous ether, wind. The negative results are generally considered to be the first strong evidence against the then prevalent ether theory, and initiated a line of research that eventually led to special relativity. If a space-filling ether were to exist, it would drastically change our understanding of physics and would have significant implications for the theories of relativity. Here's how. Contradiction with special relativity. The primary assumption of an ether is that it provides an absolute frame of reference, which contradicts the postulates of special relativity. According to special relativity, the laws of physics are the same in all inertial frames of reference, and the speed of light in a vacuum is the same for all observers, regardless of their motion or the motion of the source of light. If an absolute ether frame existed, it would mean there's a preferred frame of reference, violating this crucial aspect of special relativity. Impact on general relativity. In general relativity, the presence of matter and energy influences the geometry of spacetime, and this curved spacetime is what we perceive as gravity. If ether existed, it might imply that spacetime isn't empty but filled with this substance. This would demand a serious revision of our understanding of gravity and spacetime curvature. Depending on the properties of this ether, it could influence the bending of light and the motion of planets, potentially contradicting the precise predictions made by general relativity. Possible connections to quantum field theory. If an ether were discovered, depending on its properties, it might bear some similarity to the fields in quantum field theory, QFT. In QFT, particles are excitations of underlying fields that fill all of space. The vacuum, rather than being empty, is full of these fields and there's zero-point energy. Some historical versions of the ether bear resemblance to this concept. Implications for cosmology. If ether existed and had substantial energy or mass, it could influence the dynamics of the universe on the largest scales. It could potentially play a role in the universe's expansion, and might be related to dark energy or dark matter, two mysterious and unexplained components of our current cosmological model. In summary, the existence of an ether would dramatically affect our theories of relativity and require a significant rethinking of our theories of physics. As of my knowledge cutoff in September 2021, no evidence has been found to support the existence of an ether, and its existence is generally considered to be ruled out by a combination of theoretical and experimental considerations. However, the future of physics is always open to new discoveries and revisions of existing theories.